Hi, everyone. What we're going to be working on today is the law of sines. So, you may have done this in geometry, but I certainly know it's been a while since you've done this. The law of sines is used to find missing parts of triangles, so sides or angles, and it's triangles that are not right triangles. Okay, and specifically, we will use it when we have angle side angle or angle angle side. So this is what the law of sines looks like. And basically it states that the sine of angle A is to A as the sine of angle B is to B as the sine of angle C is to C. And when we're solving this, we'll only be using two of these fractions, not all three at the same time. So let's take a look. I don't know why this is not scrolling. There we go. And here's the first example I have for you. It says we have to solve the triangle when angle A is 33 degrees, angle B is 105, and side B is 37.9. Now, I always think it's a good idea to try to draw these to scale, at least somewhat anyway. So I would start with the fact that angle B is obtuse. I'm going to change this out because that's kind of annoying. So angle B is obtuse, and that is 105 degrees. Angle A, I'm going to put right here, and that's 33 degrees. Okay, which means, of course, this is angle C. And remember that angle B and side B are opposite each other. So that makes this side right here 37.9. Now, the easiest thing to do is to find angle C. Okay, all we have to do is take 180 and subtract the sum of the other two angles. Okay, so maybe you just do 180 minus 105 minus 33, or however you want to do it. Turns out that angle C is 42 degrees. So that's one out of the three things that we had to solve for. So now when we're doing this, what we have to do is we always have, in order to do this, we always have to have a side and the angle opposite it. Okay, so I'm going to start off with the fact that we have the sine of 105 over 37.9. And now we can choose whether we're going to solve for side A, which will be here, or side C, which will be here. So I'm going to say let's go for A. And all we're going to do is set this equal to the sine of 33, which is angle A, over side A. So notice it's sine of A is to A as sine of B is to B. We're going to cross multiply. So we get A times the sine of 105 equals 37.9 times the sine of 33. And in order to get A alone, we will divide both sides by the sine of 105. I'm going to be a little lazy here and just cross that out. And all you have to do is put this into your calculator. So when you put this into your calculator, make sure that you're in degree mode, and you should get that side A is approximately 21.4 units. Okay, if you didn't get that, you're going to want to maybe check and make sure you're in degree mode. Make sure you close this parenthesis after the sine of 33. Okay, those are things that you might want to do. So now that we have that, so that's 21.4. Now we can go ahead and calculate side C. And as I always think is a good practice, do not use the answer you just got. Go back to what you already were given. So we were given side B and angle B. So I would go right back to that, and it kind of starts off the same way. Sine of 105 is to 37.9 as, and now we're going to use angle C. So the sine of 42 is to C. Once again, you're going to cross multiply and then divide by the sine of 105. So we'll write it out, but you'll eventually get more efficient with this. This equals 37.9 times, I'm running out of space here, the sine of 42. And then you'll divide all of that. I'll do a rewrite because it does look messy. So it would be 37.9 times the sine of 42, all divided by the sine of 105. And again, when you put that in your calculator, make sure that you get the answer of 26.3. If you don't, something's wrong because that's the answer. Okay, so of course, we love our word problems. So let's go ahead and let's use this for number 2, this word problem. So we have two friends who hike up opposite sides of the mountain and meet at the top. So here's our mountain, okay, and they're going to hike up to get to the top. One's starting over here, one's starting over here. It says the first hiker walks up the mountain whose angle of elevation is 42. So I'm going to go over here and say that this is 42 degrees. The other hiker hikes up the other side and it has the angle of elevation of 37. So not as steep for that person. The distance between them at the start is 9.3 miles. So one's over here in one town, the other is over here in another town, and they're 9.3 miles apart. How long are each of their hikes up the mountain? So I'll call this angle A, which means this is side A. I'm going to call this angle B, which means that this is side B. And of course, up here would be side C or angle C. First thing I would do, I would calculate this angle. So we'll do 180 minus the other two angles. So minus 42 and minus 37. And you should get that that is a 101 degree angle up there. So now we have the angle and the side opposite it. So we will use that in both of our calculations. So we will have the sine of 101 is to 9.3 as, I'm going to calculate side A first. So the sine of 42 is to side A. And at this point, you might be able to get a little bit more efficient because we know we're going to cross multiply and then eventually divide by the sine of 101. So maybe you'll just jump right to that. It's 9.3 times the sine of 42, all divided by the sine of 101. And again, you're going to put that in your calculator. Hopefully you get the right answer, which is 6.3 miles. It's a good hike. Okay, so 6.3 miles for this side right here. Okay. And now we do the other one. So now we're going to try to calculate this length right here for person A. So we'll say again, go back to what you were given. Okay, so the sine of 101 is to 9.3 as the sine of 37 is to side B. Okay, 37 is to side B. We're going to cross multiply and then divide to get B alone. So you'll have 9.3 times the sine of 37, all divided by the sine of 101. Put that in your calculator and you find out that the person over here only had to hike up 5.7 miles. But it was a steeper hike, so maybe it was equally as difficult. Okay, so this length right here is 5.7. Okay, so what I'd like for you to do is I'd like for you to go to the next problem and see if you can draw the picture for it. Because first things first, if you don't draw the picture right, the problem's not going to be right. So please pause this video, try to draw the picture. There's real value in this. And then open it up or start it up again and see if you get the same thing as me. Okay, so I didn't quite complete my diagram yet. Let's make sure we're on the same path here. So the hot air balloon was here, and in order to look down at the building, it had to look down at an angle of depression of 65.8 degrees. Then it floated up 500 more feet, so that's what this is supposed to show. And then to look down at the building, it had to look down at you have to look down at 70.2 degrees. So we have a couple things going on here. Okay, we've got this triangle. And if this is 70.2, we can do 90 minus 70.2 to get the angle that's inside here. And the angle that's inside here is 19.8 degrees. Now that's important because we can't do these problems if we don't have enough information. And we have this side, we need this angle down here, so we have angle opposite side. Well, when it floated straight up off the horizontal, that was 90 degrees. That gives us a 90-degree angle there, which means we essentially have a triangle that looks like this. Kind of redraw it. Where this angle right here is 90 plus 65.8, which is 155.8. Okay. We also had the angle up here, which was 19.8, and this side, which was 500 feet. So what we can do right now is 180 minus 155.8 minus 19.8, and we find that this angle down here is 4.4 degrees. And that's super important because now we have an angle opposite a side. And that's really when you're able to use the law of sines. Now, what we're asking for is how far is the person or the balloon, sorry, from the building? So remember, this is the building, this is the balloon, this is the distance we're looking for. So we'll start with the sine of 4.4 is to 500 as the sine of 155.8 is to x. And you're going to cross and solve. And again, I would hope you can start being efficient here. We can do 500 times the sine of 155.8, all divided by the sine of 4.4. And listen, if you need to do that in 2 steps, you do it in 2 steps. Just make sure you get it right. Okay, go ahead and put that in your calculator. I hope you're using the alpha y equals function to get that numerator denominator fraction. And you should get that it's about 2,671.6 feet away from the building. Okay? So hopefully that all made sense. Law of sines. There you go. Have a wonderful day, everybody.